When I was starting reverse engineering, I knew the basics, how the CPU works, memory, registers, the most common assembly instructions. But I had no idea what approach to use and whether or not I'm doing the right thing. And it takes time to strengthen your reverse engineering confidence and build up your approach. So today I'm gonna reverse engineer SSD December 2020 challenge. It's my first time reverse engineering on camera, so please don't be too harsh on me. And let me fail so you can learn.
So here I just loaded the binary into IDA, and I have hex race for x86, x64, so I'm gonna be using it. So there is some stuff going on with stack protection. I don't think this will be interesting to us. Yeah, basically, yeah, I don't think that it will be interesting at this stage, except that there is some interesting function E. So, and here we can see training jump table. So this function might be related to exploitation, maybe some exploitation primitive that is built into this task. I don't know yet. So let's take a look at function h, which takes exactly 3 arguments, the same as all arguments are the same as arguments to main function. It outputs some text. And it calls function setVbuff. Yeah, it's a library function, but I'm not familiar with it yet. Then it calls malloc. It allocates some buffer. Okay, here here you can see that the code reads. Here we can see that the code reads name from stdin, and the name is supposed to be 14 characters long. Then strtalk function looks for end of the line character. Then it reads something called anger. Into the start of the buffer, and it initializes different part of buffer with this XML word. Okay, some random stuff. Read. Surrend. It's time to begin your journey. Okay. Just to have better understanding and to have prettier code, what I'm gonna do is to allocate structure for this buffer, because clearly because clearly some kind of structure was used in original source code. You can automate the task of making structures with different plugins. I personally prefer Hex-Ray SpyTools, but for the sake of simplicity, I'll do it with vanilla IDA instruments. So let's go to structure view. Let's drag as it called in the code, and I input 1 byte, and I'll make it as an array, but not really an array, just I'll make 428 in hexadecimal elements, and now I'll type it as my struct. Okay, yes, here it is. And so needs to be retyped, yes. So this field will be name. The first field I'll rename to Anger in anger. Yeah, sorry, anger. So you're supposed to enter how angry you are. Okay. So this I'll remain to const number 4 I. What is I? I is a function. Okay. Function I. This is number 1. Those are not final names, because right now I have no idea what these fields are used for, but I usually use temporary names just to make things a bit easier for myself, and while I'm working I constantly renaming some stuff, so okay. And here that I forgot to rename this to number 40. Okay, need screen library, cbreak, library admin. Okay, so I suppose that this function just do some magic related to output in terminal. Here we can see that PVP is also heap buffer, and we are opening new random, and we are reading from urandom. We are reading 4 bytes. Right now I don't know why is it right now I don't know why negative offset is used. It's a bit unusual, but it happens. We can see what's going on in the assembly code. So yeah, basically it's some kind of structure with a negative offset. I think it might be related to stack canary checking. I don't know yet. So all we know is it is filled with some random number, and this is pretty much it. Let's take a look at the rest of the code, and you can see that the code sets handler for signal 5 and then sends signal 5 to itself. So I think it's safe to say that this all have been done only to call this function e. So let's see what it does. It takes field from MMM structure, field we don't really know much about, so let's go to function f and see what it is doing with our field. So the field is a pointer, right? It dereferences this pointer, okay. So it dereferences it, and I think it might be set to 0. Let's go back to function h and rename remaining fields. Yes, this field is initially 0. I'll also remain the remainder of the fields. Okay. So let's go back to f, and here we can see a comparison of this number, and if this number is 0, which we know initially it is, function t will be called. So switch case, it's called with 0 as an argument. So if it's 0, then it outputs some strings and calls function j. This function calls function e, which outputs help, so I can rename it to e output help. You can use period, star, and head to call some actions. So you have some kicks and punches going on, and those basically are some output or encoding of some moves. So okay. Let's see what function b does. So it does some math. Those are what I presume are names of the fighters. So what I think it's makes a new structure for a new fighter here. Yeah, something like that. Maybe some of his strength or punch strength. So I can rename it to be make new fighter. So here in the loop, I think that based on this string, this is a round count, and this should be total number of rounds. And here we can see that this argument is first, and at the start we have only one round to fight in. I think K is basically the function where all fighting is processed. Yeah, okay. Let's put it aside for a while. Oh, here we can see function bug. Alright, let's go right into it. Okay, so for some reason hexrace doesn't want to decompile this function. And I don't really see it popping out in assembly code. I'll try to find it in... No. So here you can see comparison with 6, so we can try and find it here. Yep. And the bug is triggered if input is more or equal than 6, so this jump is jump not below. It's here the function is called, is correct? Yeah, function I is called here, and here is our bug. Let's change view, so it's only one instruction I'm familiar with, UD2. It's quite interesting what it does, doesn't it? Okay, let's try to find it. UD assembly UD2. Define instruction. Okay. Generate an invalid of code. Function for simulate testing to generate invalid of code. Okay. So the exception is erased. And bug is not a function. And bug is not a function. It's hexrace is trying to tell us that invalid behavior will be triggered. So what I think is going to happen is that the CPU will throw out an exception and some exception handler will be called. And what I think some of the code you have seen might done is it was setting up extraction handler, maybe somewhere. I'll try to find it, and then yeah, it will be triggered.
So what have we learned? First of all, I thought that the reverse engineering portion of the challenge would be quite easy, and it wouldn't take me more than half an hour to be done with it. And that's why I didn't even attempt to run the binary itself. And it would have saved me a lot of time, and I was really wrong by not doing it. Second of all, we've learned that the biggest part of the challenge logic probably resides inside the exception handler, and that's what we are gonna be reverse engineering next time. And that's it for today's video. If you have any questions or suggestions, please leave a comment below. Subscribe if you want to see the next part of this video. And until next time, take care, my friends.